This video today is about the operation of this Powermatic Model 90 wood lathe. I restored this machine about 6 years ago and recently did some upgrades. This video series is in two parts. In this video, we're going to talk about the mechanical operations of this thing. Then in part two, right here, we'll talk about how the VFD, variable frequency drive, is set up and how the low voltage control circuits work to control the VFD, which controls the three-phase motor that was originally in this machine. But before we do any of that, let's just see how it runs. This is the main AC power that turns on the VFD. And this is the power switch that tells the VFD to send power to the motor. This is the potentiometer that controls the VFD output frequency to the motor. And the digital display is an RPM sensor for the spindle. There's also a reverse switch. The default, though, is forward. And that's why there's a safety cover, because reverse can be a little dangerous. I have the VFD configured to send from 0 to 80 hertz to the motor. Now the mechanical original Reeves drive still works in this machine, so you can also adjust the speed through a mechanical method that was originally part of the machine. So there's really two ways to control the speed now in the machine. One is the original Reeves drive, which we're going to talk about in detail today, and also the VFD controlling the frequency output to the motor. So essentially now the machine is set up to have speed control through the VFD and motor control, and then the original speed control on the mechanical side winds up to be a torque control. So you really have great control over the machine. Here I have the Reeves drive at the slowest speed, and then I've also set the potentiometer so that the VFD is sending only 1 hertz to the motor. It didn't register on the RPM readout, but it's about 4 RPMs, the slowest speed possible, under this configuration. Nice. I bought this machine from a fellow that had picked up this machine and some other equipment all from the same spot, and it wasn't running. It was in parts and pieces in the corner of his shop. He planned on running it, but he didn't realize it had a 3-phase motor. He didn't have 3-phase power, obviously. So I took it all apart, dragged it home, and most parts were actually there. But I did have to replace several things and buy a few things off of eBay. According to the serial number here, this is a 1973 vintage machine. This lathe weighs about 600 pounds. It's got a 38-inch bed capacity. The base is just 14-gauge steel, welded into a big box basically, with a diagonal piece in the middle for stabilization. The bed is a 1/2 inch thick cast iron, pretty much, and it probably weighs 300 pounds. I had a heck of a time moving it around the shop when I was restoring it. The tailstock and the bed surface cleaned up real well. A fair amount of surface rust and other junk on there, but quarter of a turn to move the tailstock, tighten it down, that's pretty good. The quill was in good condition. Morris 2 taper was also good. There's a cutout that engages a spring pin in the casting to keep this thing from spinning. I wanted to show you one part I had to replace. I was able to find a new quill feed screw from a company in Georgia. I was real happy to find that. The old feed screw was terrible, but this made it brand new. I also had to order a new revolving handle for the hand wheel. That part was just missing. Nope, you had it right the first time. There you go. The tool rest works great now, but when I first got it and started tearing it apart, there was a lot of surface rust and burrs and maybe even some abuse to the thing. It's really a nice, simple tool. It's got an eccentric shaft, so as you turn the shaft, the locking nut underneath is loosened or tightened. There's no bronze bushing on the far side, but there's one bushing which I replaced on the handle side. Now, once I got it all cleaned up and adjusted properly, it worked pretty good. Okay, let's take a look at the headstock. This is this variable speed dial. And the original machine, this was the primary control for everything, speed and turning the motor on and off. We don't have very good light here, so I moved it over to the bench so we could see it better. The speed control is a cam system that works on this speed dial, which moves this roller assembly in or out relative to the center of this dial. And between large and small, it's only about a 5/8 of an inch difference. And there was a lot of wear on that surface, and you can see how the roller assembly rolls on that cam. Up spending a couple of hours hand filing that cam so that it was back to 90 degrees and it was relatively consistent all the way through its length. That took a while. Interestingly, there is a speed control nut where the shop instructor at a high school shop class could control the maximum speed on this speed dial by putting that screw in any one of these, 6 positions there. I thought that was kind of interesting. And finally, there is a circle with a small cutout. This is to prevent the locking pin for the spindle from being pushed in if the lathe is in any position other than stopped. So you can see here, when that little pin was in place, the spindle lock would not work. And it only worked when the speed dial was in the off position. Well, that presented a problem because I moved the on-off controls away from this altogether. So I built a little safety cover that at least reminds me, be careful when you push that spindle lock in. Make sure the spindle is not moving. Okay, we're going to take the faceplate off and the belt guard off and take a close look at this continuously variable transmission. You know, before we talk about the continuous variable transmission, which is what this is, and commonly called a Reeves drive, because the inventor, Milton Reeves, was really an interesting fellow. Born in 1864, he invented this variable drive when he was 15 years old working in a sawmill. He later went on to have over 100 patents, worked in the automobile industry, worked in making small engines and obviously transmissions. But he was one of the first people in the 1890s to build a automobile. And it was one of the first cars to actually have a transmission. It was a very good one. It was a variable speed transmission. And how many of us who enjoy old cars have not run across this photograph of the Octo car, and also the sister of the Octo car, the Sexto car? That's right, Milton Reeves. Interesting fellow. Power comes from 1 horsepower motor up to a jack shaft that had different configurations, different pulley sizes, up to the variable speed drive. I got to be careful here not to smash my fingers on this spring-loaded pulley as I take off the belt. The belt for this thing is a little more robust than you would expect from a typical V-belt. A little wider, and as in all belts, the friction is on the side of the belt, not the bottom. And the angles here match perfectly to the sheaves in the pulley. Powermatic calls this piece a roller, but it's actually a cam follower. And it pushes the inside sheave of the pulley in and out, adjusting the size. So the smallest size is about 2 inches, and the largest size is about 6 inches. And that's what varies the speed. Then you get exactly the opposite effect on the lower pulley. And it is simply reacting to what's going on up above by this spring, making this pulley larger or smaller. So now we'll put this thing back together and watch how the pulleys change under different speeds. When you install this belt, you got to put the spring-loaded pulley on first and then work the top one on. They're on pretty tight to provide enough friction. We're starting out at slow speed here and then working the drive up to fast speed. And you can see the top pulley is getting smaller and the bottom pulley is following it with the spring. We'll just cycle through again just for fun. Well, that's it for the mechanical part of this series. Next time we'll talk about how the variable frequency drive is set up and how it controls the 3-phase motor in this machine. Leave me a comment, I appreciate those.